All right, so we've been doing these BCA calculations, and remember, all that means is we're going to take the reactions that we know how to do. We know how to write formulas, predict products, and balance equations. Now we're talking about how much product can be created, or how many reactants are needed to create a certain amount of product. Okay, and we've been doing that. We've been taking an amount, converting it to moles, doing the BCA, and then converting it back to grams to figure out what is the mass of a product that we can create. But we've always just been using one of the reactants. Well, most reactions, other than decomposition, have more than one reactant. So we're going to deal with that now, and it's something called limiting reactants. We're going to find which one of the reactants we need to use to do the BCA calculations to figure out how much product we have. An example would be here, like gasoline, burning gasoline in your car. So you can go fill up, and you fill your tank up with gasoline. It's expensive. When you're all done, you get back into your car, and you start driving away. And as you're doing this, you're burning gasoline, C8H18, with oxygen, and you're pushing out CO2 and water. But if you notice, your gas tank is going down. So that's the point of this. In this reaction of gasoline plus oxygen, are you going to run out of oxygen? You've got the atmosphere full of oxygen. What you're going to run out of is gasoline. And once you run out of gasoline, the engine's going to stop, and you're going to slow down and come to a stop. Right? And the key to this is that it's the gasoline that you ran out of. It is the limiting reactant. The oxygen is in excess. Okay? And for us, that means that when you do those BCA calculations, you have to use the amount of the limiting reactant, the one that's going to run out. That's how you determine how much product you can make. If we were to use the oxygen, if you look at the oxygen, that's 100,000 million, billion, trillion, quadrillion, quadrillion. That's 1 septillion, 80 quadrillion grams of oxygen in the atmosphere. Okay, and if you converted that to moles, that's 160 quadrillion moles of oxygen in the Earth's atmosphere. We wouldn't use that number to calculate how much product we'll make by burning all the gasoline in the tank, in our car's tank. You'd never use something that you have in excess to do the math. You always use the limiting reagent. And if this car had like a 10-gallon tank, that's about 270 moles of gasoline, you wouldn't use the excess oxygen to calculate how much you could produce. You would use the limiting reactant, 270 moles. You'd use it all up, which means you'd use up, so you divide by 2, multiply by 25 to get 3,375 moles of oxygen used up. You'd divide the 270 by 2, multiply by 16 to get that you're going to create 2,160 moles of carbon dioxide and 2,430 moles of water. And this should kind of show you what we're worried about with climate change. You burn a tank of gas, you make a lot of CO2, because look, there's a lot of carbon, and you're using a lot of oxygen. You're certainly making a lot of carbon dioxide. But the key is that you're going to use the limiting reactants numbers to do the math for everything. You're not going to use the excess reactants numbers. And for us, the easiest thing to do is to just do these calculations with both reactants. Do this, use the 270 from the gasoline, figure out how much everything can be made, and then do the calculation with the amount of oxygen that you have, or the amount of the other reactant, and the smallest amount of product is the correct answer.